Okay, so today I want to show you how to solve limiting reagent problems using the end product method. So take a look at this example problem. We've got 5 grams of iodine. It reacts with 0.531 grams of aluminum to produce aluminum iodide. How many grams of aluminum iodide are made? Well, the first thing you have to figure out is, are we going to run out of iodine first, or are we going to run out of aluminum first? Now, you might want to take a moment and try to guess, but you'll probably be wrong. You only have a 50-50 shot. These numbers, while they look different in terms of number of grams, off by 10-fold, it's not exactly completely clear which one is going to run out first. So the very first thing we have to do with any problem is write a balanced chemical equation. So for this one, we're going to have iodine reacting with aluminum to produce aluminum iodide. And in this case, it's actually catalyzed by water, so we'll put a little water there. And in order to balance it, we need 3 iodine, 2 aluminum, and 2 aluminum iodide. Now, the reason why we need a balanced equation is because we're going to need the mole ratio in order to solve this problem. So let's dive in and show you how to do it. The first thing you have to do is figure out what you're starting with and what you're ending with. Start, end. Now, in this method, we actually are going to pick the endpoint, and the endpoint is going to be grams of aluminum iodide. But what is our start point? Well, actually what we're going to do is we're going to solve 2 equations in parallel, and starting one with 5 grams of iodine, and the other one starting with 0.531 grams of aluminum, and then calculate how many grams of aluminum iodide each can make. When we finish, whichever one makes the least number of grams of aluminum iodide, whichever reagent that was that started, whether it's the aluminum or the iodine, that one will be our limiting reagent. So our start is 5 grams of iodine, or 0.531 grams of aluminum. And our endpoint for both is grams of aluminum iodide. Now, you might recognize this as a gram-to-gram type problem. Well, it is. So the first thing we have to do is convert each of these into moles, because everything goes through moles. So in order to do that, we have to multiply by 1 mole over the molar mass in grams. So 1 mole iodine is something like, let's see, 253.8 grams of iodine. Down below, 1 mole of aluminum is 26.98 grams of aluminum. That's just the average atomic mass. Now the middle step is the mole ratio. Okay? That's why we needed the balanced chemical equation. So we need to go from moles of iodine in this case to moles of aluminum iodide. Using the ratio, we put what we're moving to on top, so it'll be 2 moles of aluminum iodide, and what we're coming from on the bottom, which will be 3 moles of iodine. And the top is going to be the same for the bottom equation as well, because we're still going to aluminum iodide, but the bottom is going to be different because we need 2 moles of aluminum. So what we've done so far is we've converted from grams to moles, moles of one substance to moles of our target substance, and now what we really have to do is do the last step, which is another step involving molar mass, but now the grams will be on top instead of on the bottom. So last step, we have to figure out what the molar mass of aluminum iodide is. Molar mass of aluminum iodide is 407.71. So 407.71 grams will be on top for both of aluminum iodide. Per 1 mole. Okay. And then all we have to do is solve it. And that's going to be 5.35 grams of aluminum iodide in the case of starting with 5 grams of iodine. Or it's going to be 7.22 grams of aluminum iodide when we start with 0.531 grams of aluminum. Do you notice that if you would just look at the initial amounts, you might have thought, well, God, there's so much iodine, you know, there's 10 times more mass almost. That's got to be our limiting reagent. Well, that's not true. All right, it has to do with the mole ratios, which is one of the things that's going to change it. So which one is our limiting? And you want to know the number of grams produced? It's going to be 5.35 grams.